Okay, today we are talking about probability. We are going to talk about the probability of an event happening using theoretical and experimental methods. And it's what probability is the likelihood that something is going to occur. Probability is it can be represented as a fraction, it can be represented as a decimal, or it can be represented as a percent, all three. The probability of something occurring can range from 0 to 1. For example, if I had a die and I rolled the die and I said, what is the probability, so what is the chances of this happening if I asked you to roll a 7 on a standard die? What are all of the numbers on a die?
1 through 6.
1, 2, 3, 4, 5, or 6. So if I say, what's the probability, how likely is it going to happen that you roll a 7?
0.
0. It's impossible. What if I say, what's the probability of you rolling a 1, 2, or a 3? What you do is you take the number of times the event could occur, which is 3, 1, 2, 3, over the number of possible outcomes. There's 6, right? So 3 out of 6 is either 0.5, you can write a half, or you can write 50%. So if I said, what's the probability that you rolling a 1, a 2, or a 3 on a die? Well, there's 3 out of 6. So you can write this as a fraction and you should reduce it, or you could write it as a decimal, or you could write it as a percent. So 3 ways you can write this. Now, so I said, what's the probability of rolling a 7? You said 0. What's the probability of getting a 1, 2, or 3? You said 0.5. What's the probability of getting a 1, 2, 3, 4, 5, or a 6?
6 over 6.
6 over 6, which is equal to 1, which is equal to 100%. So probability is a number that ranges from 0 if it's impossible, all the way to the number 1. 1 is going to be, it's certain it's going to happen for sure. So, what is an experimental probability? Is you're basing it based on observances, an experiment. So for example, here's a good problem. There's 60 vehicles in the teacher's parking lot. Out of those 60 vehicles, so 60 is the bottom number, the denominator. Out of those 60, it was observed that there were a total of 15 pickup trucks. So if we ask P pickup truck, that means what's the probability that you select a vehicle in the teacher's parking lot and it's going to be a pickup truck? Well, what you're going to do is take the number of pickup trucks in the lot divided by the total number, and that's probability. So you have a fraction, 15 over 60. You can reduce it, by the way. You can reduce this. You can write it as a decimal. How do you get 0.25? 15 divided by 60 is 0.25. Or you can write it as a percent. So the probability of a vehicle being a pickup truck is 25%. You try the next one. Got it. You've got a softball player. Okay? Softball player is hits 20 of her last 50 times at bat. Can you tell me, I want you to write it as a fraction, and as a decimal, and as a percent. What's the experimental probability? And this is an experiment, because what they did was observe that 20 of her last 50, she hit. That and in words. Yeah. When you're done, I'll give you this. So, does anybody have an answer for me yet?
0.4.
Okay, 20, it'd be 20 over 50. Now, you know these two zeros cancel out. You could have 2 over 5, You could have 0.40, or you could have 40%. Those are all three good ways to write the probability.
I read it.
Now, sometimes when you're conducting an experiment, sometimes it's really impossible to figure, it's very difficult or very unreasonable to figure out what the probability of something to happen would be. So they'll do a simulation. So like a lot of times, like when there's a big thing happening, for example, an election, for example, and they want to figure out what the probability of so-and-so winning is, what they'll do is take a sample, they'll do a simulation, they'll take a rough group of people, and then they'll figure out how many people pick this person over the total, and that gives them an experimental probability using a simulation. Okay, flip it over, please. Okay, so the set of all possible outcomes in an experiment is your sample space. When each outcome of a sample space has the same chance of occurring, we have equally likely outcomes. And that's when you are going to use theoretical probability. Theoretical probability is not based on an experiment. If you think about a deck of cards, how many cards are there in a deck? 52. So if I asked you what's the probability of getting a jack, how many jacks are there in a deck? 4 out of 52, okay? That is theoretical. You're not you're not basing it on an experiment. If you think about a die, how many faces are there on a die? 6. That's theoretical probability because all the faces are the same and one does not, it's not based on an experiment. So here's an example of theoretical probability. What's the theoretical probability? We're not doing an experiment. We're doing theoretical probability of you rolling a 5 on a standard number cube. That's a die. So, well, there's 6 faces on a cube. 1, 2, 3, 4, 5, 6, and there's 1 5. So we have a 1 out of 6. Well, what if I ask you to roll 2 dice? And I say, what's the probability that you roll the 2 dice and the sum of the 2 numbers is a 5? So if I rolled 1 die and it was a 1 and the second one was a 4, that'll give you a 5. If I roll the first die and it's a 2 and the second one's a 3, that adds to be 5. What if I rolled the first die and it was a 3? I'd have to get a 2. And then the first die is a 4 and a 1. So in other words, these are flip-flopped. Those are the only ways to sum up to be 5 with 2 die. There's no other way, okay? So how many situations occurred where we got 5? 4. Out of the total fundamental counting principle, there's 36 different ways to roll a die and get a different number. So there's 4 favorable outcomes over 36 possible outcomes. So 4 out of 36 can be reduced as 1/9. You could also turn 1/9, if you turned 1/9 into a decimal, 1 divided by 9, that's what that does, 1/9. And if you want to convert it, go to menu, actions. You want to convert, go to number. Convert to decimal, and then hit enter. And there it is, it's about 11%. Okay, let's try this next example. Okay, so what's the theoretical probability? You've got 2 dice and you're gonna roll them one at a time. I wanna know what's the probability of getting a sum that's an odd number. What are all the possible numbers you could add to be? What's the biggest number you can roll with 2 die? What's the biggest number? 12. So in other words, 2 to 12, right? That's the sum. Can we do less than 2? No, because if you have a 1 and a 1, that's 2. 2 to 12. So out of this, 2 to 12, list all of the odd numbers, all the odd sums. What would it be?
3,
3,
5,
5,
7, 9.
and 11. Those are the numbers we're looking for. Okay, so let's look at how many possible outcomes there are. So we have, if we roll the first die and we get a 1, what do we have to have with this? A 2,
An even number.
an even number. Good job. Those will all add up to be an odd number. So a 1 with a 2 gives us 3, 1 with a 4 gives us 5, and 1 with a 6 gives us a 7. So that's the first die and the second one. How about a 2? All the even numbers with a odd. So 2 and 1, which will give us 3, 2 and 3, which gives us 5, 2 and 5, which gives us 7, and that's it. Because 2 with a 6 gives us 8, and that's even. Okay, how about 3? 3. An odd number with
Even.
an even, good. So 3 and 2 gives us 5. 3 and 4 gives us 7. And 3 and 6 gives us 9. So that's good. How about 4? 4, an even number with the odds. So 4 with 1, 4 with 3, and 4 with 5. Those give us odds. Let's do 5. An odd with an even. Are you guys following me here? The first number is the first roll, and then the second roll. So then 6 even with the odds. And that's it. Now, what if the first one was a 2? It'd have to be a 1, and we have it here. What if the first one was a 4, 4 and 1, we have it there. So all of these, we already have the flip version in this list. So how many possible sums did we get that added to be an odd number? How many did we come up with? 6, 12, how many? 18. We came up with 18 possible ways out of a total of what? How many? What's this bottom number going to be? How many, if you roll a die, how many choices can you get with the first die? 6. And if you roll a second one, how many choices? 6. What's 6 times 6? 36. There's 36 possible outcomes. Out of those 36, 18 of them could give you a sum that's an odd number. So how can you write 18 over 36 differently? 1/2, or 0.5, or you can write 50%. Questions? Now, the last kind of probability is called geometric probability. And a good example would be if you were playing darts, you have a circle, and you want to land right here. And this is called the, what's this called? Bullseye. Good job, bullseye. So if I wanted to know what's the probability of landing in this bullseye area, what you would have to do, and this is one of your homework problems, so I'm not going to tell you the answer, you would have to figure out the area of this circle right here. So the probability of landing in the bullseye would be the area of the bullseye over the area of the circle. Meaning, from here to here. And how do you find the area of a circle? Pi r squared. Okay? So in your homework today, there's one of these problems, and I want you to use r radius as 1. They give you, and when we get to that, I'll show you. They give you a radius of 1, and they break the circle up. They're saying this is 1, this is 1, this is 1, and that's 1. Okay? We'll get to that in a minute. Let's look at this example right here. So we have a batter who has this strike zone, and the strike zone has been determined that it's based on the height and the stance of the batter, which we're not gonna figure out what each individual hitter's strike zone is. But according to this batter's strike zone is 17 inches this way and 22 inches based on his height and his stance. So what is the area of his strike zone? Would be all of this. You would do, how do you do area of a rectangle?
Base of, base times width.
Length times width. Length times width. So what is 17 times 22?
374.
What is it?
374.
374. Okay, 374. Now they want to know what's the probability, we have this called, it's called high inside strike area. And if the pitcher pitches in this little area right here, it's extremely difficult for this batter to hit the ball. And the high, it's called the high inside strike area, measures 4 by 6 inches. So they are asking you, what's the probability that the pitcher will pitch right in this little area? So what you're gonna do is the area of the high inside strike area, which is 6 times 4, which is 24, over the area of the entire amount. So how you do this, you're gonna do the area of the high inside strike zone over the area of the entire strike space. So 6 times 4 over 17 times 22, and you get this decimal, so it's about 6.4% chance, very low. That's why pitchers get paid big bucks. So now, number 5. Suppose that a batter's strike zone area measures 15 by 20. That's his strike zone. And then the high inside is 3 by 5. Can you tell me the probability that the baseball thrown will be in this high inside strike zone area? Can you tell me?
15 over 300.
And what'd you get? 15 over 300. Can you convert it to 8%?
5%.
5% is correct. Good job. So there's a 5% chance that the pitcher will hit within this high zone area. Okay? Those are your notes. So the back side's gonna be homework. I'm gonna turn that off.